Yes, my name is Don Criley. I'm a member of the OpenROAD development team. Welcome to the Hybrid Data Conference. And what I'm going to discuss in the next half hour is WebGen 101, which is basically a utility that allows you to take OpenROAD applications and deploy them on the web. This is WebGen 101. WebGen 101, WebGen itself was actually presented earlier by Chris Clark as sort of on the path to modernization of applications. There was a slide, I believe it was his 10th slide, where on the left you had an ABF application, and then in the middle you had an OpenROAD application, and in his session he discussed methodologies to bring things from ABF to OpenROAD. On the right side of that slide was WebGen, and this session is related to that utility. So the purpose of this presentation is to tell you what it does, how it does it, and when I have on this slide, what does it not do? It's not so much what does it not do, it is where we are now. And then finally, there's a couple slides related to, now that you've run the WebGen utility, how do you actually deploy the applications in a web browser? The web browsers that we currently support are Firefox, Chrome, and Microsoft Edge. Okay, here's a nice little diagram, and this from a sort of a very high level explains what the WebGen Transpiler utility does. And the thing is, what is a transpiler? Basically, a transpiler converts source code from one programming language, in this case like 4GL, and converts it to another at the same level of abstraction. What they mean by that is that a lot of compilers, will take, for example, C code and turn it into assembly language, where that assembly language is actually really binary and is what is run. In this case, with a transpiler, it's basically converting one programming language to another, kind of like translating French to English or Spanish to Russian. They're both at the same level of abstraction. Basically, the output from the transpilation process is JavaScript, which represents the program logic that you actually coded in as 4GL, and HTML, which is what causes web pages to be rendered within a browser. And within that HTML, we actually embed CSS, which stands for Cascading Style Sheets. We use some in the HTML, has some that is like hardwired, just stuffed cascading style sheets that are used for bootstrapping purposes. Then for whatever frame the HTML is for each field, it has inline CSS properties that allow you to, they have different foreground, background colors. They specify things like size and positioning, and there's various other things like, is it mandatory? Other sorts of properties that you can specify with CSS. But on the left here, we have something called calc_app bang adder. Calc_app is the name of the application. Adder is the name of the frame. So what you will get is, because the frame's name is adder, you'll get an adder.html. There's one HTML per frame. And calc_app.js, you get a single, now I'm going to have to go into this a little bit more, but you get a single JavaScript file for the entire application. So if your application happens to have one frame and 5 4GL procedures, they'll all be merged into this one JavaScript file. The thing is, in your scripts though, in your 4GL script, the thing on the left, we're only currently supporting 2 types of OpenROAD events. That is clicking on like a button and set value, which means if you, for example, type something into an entry field, you're actually setting its value. By only supporting these two events, those are the only type that you can script. So you can't have on-click point or things like that. Right now, it's only on-click and on-set values. Once the transpiler generates these files, like I said, one JavaScript file for representing the entire application and one HTML file for each frame. Do not change them. They're very tightly bound, and if you make a mistake, you'll break the whole thing. Now I'm going to go a bit deeper into what the transpiler does. It basically follows the same, I guess, if you want to call it, the same process that ABF goes through. When you transpile your using WebGen, you're actually doing two things. First, you're compiling the 4GL, the stuff that's been typed in, and this is both for OpenROAD and WebGen. What is produced is something called intermediate language. We call it IL for short. It's kind of like OpenROAD and ABF's assembly language. When you run something in an interpreter, it's actually executing IL code, not what you typed into the 4GL. So what happens with the transpiler is it first unconditionally compiles the 4GL into IL. And then what it does is it takes that IL and converts it to JavaScript and HTML. A lot of, with OpenROAD, you have this thing called core.pob, which has a lot of core functionality. We have a JavaScript version called orcore.js, and in that we have core functionality. To be honest, a lot of what our ADF, abstract data type facility, does. On top of that, it has system constants for like errors and things like that. But anyway, it's sort of a resource that's required by WebGen apps. OpenROAD, unlike ABF, is object-oriented and supports inheritance, and guess what? So does WebGen. I basically have a way of picking apart hierarchies of user classes and creating constructors in JavaScript from them. So we support inheritance with WebGen also. One thing where ABF and OpenROAD differ is the event model. This is kind of a side story, but if you look at the IL for OpenROAD and ABF, they're very, very similar. Matter of fact, some statements, whether they be from OpenROAD or ABF, these are the IL statements, actually do exactly the same thing. One big difference, though, is the event model. With ABF, you have things like FRS keys and things like that. With OpenROAD, you have like menu clicks and things like it's basically something that allows interaction with mice and other sorts of things. So essentially, with WebGen, you take the 4GL as typed in, it gets merged with the symbols from the frame. These are all derived from the frame source for the OpenROAD frame. The OpenROAD frame source not only contains the scripts, basically the 4GL, not only sort of the hierarchy of fields, it also has IL, which sort of a compilation to IL uses the frame definition for the fields and the 4GL, compiles it and converts it into IL, and which is, like I said, sort of the OpenROAD interpreter's version of assembly language. Then the transpiler takes that IL and converts it into JavaScript. So it's a two-part process: compile to IL and then translate the IL to JavaScript and HTML. Okay, here's a sort of a biggie. Generally speaking, with web browsers and JavaScript, things are designed to be asynchronous. The reason this is so is that you don't really want certain operations hanging a browser. independent, sort of, if you want to call it, atomic operations should be done asynchronously so that one thing doesn't block another. For that reason, among others, and also I should say security, things like a SQL injection, to get access to data from a database, you have to go through an OpenROAD server. And to get to the OpenROAD server, what you need to do is you need to use, and we've introduced a system class, not only in OpenROAD 4GL, but it's also been implemented in JavaScript, the Json Handler classes. There's Json Handler, there's Json Number, various system classes that are JSON specific. Those have been ported to JavaScript and are created using WebGen. The Json handler has a function call, and it's called, I got it right here, it's oh boy. Anyway, it has a function call that allows you to send RPC requests to an OpenROAD server. In that RPC request, you, in JSON format, pass parameters to the function in the server that's going to be called, and what gets returned to the RCP request is a result. We have another function that's in OpenROAD's core.pob, but it's also been ported to JavaScript, which is assign JSON, JSON RPC response to vars. And what that will do is it'll package up, or take what came back from the OpenROAD server and basically fill the variables in your WebGen application up with the results from the query. Not only do you do queries from this OpenROAD server, you can also introduce all sorts of business logic. So not only do you have database access, you have business logic, and because it's an OpenROAD server and uses the RPC mechanism for calling procedures, you can actually call procedures in the OpenROAD server using other clients other than like WebGen clients. So basically it makes up the OpenROAD server available to, I guess, pretty much anything that can do RPC calls. Okay. We do not, with WebGen at this point, support all application component types. Obviously, we do frames. That's where the HTML comes from. You can have standalone 4GL procedures, and you can also have local procedures in your frames. We allow user classes and arrays of user classes, and also those user classes can take advantage of inheritance should they be subclasses of another class. WebGen can take care of all of that, and of course global variables and global constants. The other component types that we do not currently support are, for example, calling a 3GL procedure, calling database procedures. There is another component type which is like just basically an include script. That has nothing to do with WebGen, and if you have include scripts that you put into your procedures and frames, those will be supported too, because those are handled by the 4GL preprocessor, and that occurs well ahead of WebGen. Okay. We couldn't implement everything, but what we've done here is we've attempted to create what we call a minimal viable product. Basically, it has to be useful, and you'll see later on an example where I actually have a little calculator application that we use for a demo. Your WebGen is not targeting things like ERP applications, and if you happen to know that the OpenROAD Workbench is actually an OpenROAD application, that's not a candidate for WebGen. WebGen is primary target is like mobile platforms, something that's simple to interact with, that you might even want to, sort of suitable for a web, like a smartphone. Like a little banking application. Not a lot of widget types, maybe a few lists, checkboxes, entry fields, buttons, and things like that, but not things like list views, tree views, UI widgets like that. So we do not support all system classes, and we basically a subset of the UI, the user interface system classes, entry fields, button fields. I have a list down below there. What we did is we sort of all sat together and, you know, we have a lot of experience in our group. Like, for example, I've been with Actian since 1988. So we have a lot of experience, and we have a pretty good idea of what our customers have been doing, over the last few years. And so we identified the UI widgets that are most commonly used, most commonly used, have the most powerful, I guess I should say. And another thing is there a way that we can take an OpenROAD entry field and map it to like an HTML type, that will give us equivalent functionality? There's something I failed to mention in one of the earlier slides, is that if you look at the HTML that WebGen generates, and you're familiar with HTML, you'll see elements with tags that happen to have the same name as OpenROAD system classes. For example, you might see a left angle bracket entry field, where you might normally see like input. You might see button field instead of button. What we've done is we're using a third-party product. It's a JavaScript framework called Vue, V-U-E. And Vue, if you're familiar with HTML and web programming, you're probably aware of React and Angular. Well, this is yet another one. It's called Vue. It's pretty popular. It has a very thriving user community and developer network. But one feature it has is what they call mapping sort of HTML primitive entities, things like input, button, things like that, and giving it extra power by calling it a view component. And once you've defined view components, you can sort of do much freer to do like OpenROAD sorts of things with it. One thing you do get when you do that is that the syntax that the WebGen Transpiler does is it creates, and this is not done by magic, but by design. Basically, the JavaScript that's generated is just really mimics very closely what you typed into the 4GL. In other words, you can look at the JavaScript and say, oh, I know exactly what this did. And you'll see, like, because it has the sort of the entry, because it follows the pattern of the entry field and the button field. And therefore, as far as the JavaScript, it looks like it's very native. So when you look at HTML generated by WebGen, you'll see tags that are not simple HTML tags. They're actually what we call view components, and we've taken advantage of that because it makes everybody's life simpler. And here's the thing about these: not only Vue, but also React and Angular. You get what they call double binding, or as Vue calls it, reactivity. And what that means, and this is what you get automatically, and this is the whole point of using something like Vue, is that when you enter something into your web page, and it might be in like an OpenROAD entry field, or basically an input field in HTML, what you type in automatically gets set in the underlying JavaScript variable. That's one way it's binding. The other way is that if you actually go and change a JavaScript variable that points to like an entry field, and you go and actually put a value into it, it'll all of a sudden magically appear in the entry field in the web page. So that's the double binding that using Vue components buys us. It does it automatically. There's not a lot of fuss and muss. There's no extra coding. It's like almost like magic. So we use, once again, this JavaScript framework called Vue, and it's kind of interesting to look at. It's very powerful, and it saves a lot of work, and it does a lot of things for you automatically that it's easy to figure. It would be very hard to duplicate what it does on your own. So what are the simple UI widgets that we do support with WebGen? Obviously entry fields and those things that are derived from it, things like free trim and box trim, and of course button fields, which also have a toggle field. Composite fields. The reason we did composite fields, even though they don't typically have sort of a data area, they're basically composed of child fields, but by supporting composite fields as a view component, it allows us to do something which you're going to see in a moment is very powerful, which is we can actually implement attributes on the view components, whether they be scalar, things like entry fields, or whether they be composite fields. The attribute I'm talking about is cur bias. If you take a composite field and in your code you say make its bias FB invisible, not only will it disappear, but all the children within it will disappear. So this is, once again, the power of using view components. So we're going to take advantage of that to whatever degree we can. But right now, yeah, we have the most commonly used widgets or UI elements implemented, and we decided, once again, what are the most popular, what are the most useful, and also how easy is it for us to actually ensure the same type of behavior in a web browser as we would in an OpenROAD application. And just a little bit more, certain UI elements that you see in OpenROAD applications, which are very powerful, very complex, things like tree views and list views, they're actually in OpenROAD based on the Win32 API, and they're to make them work in a web browser, we'd either have to find a package that does something equivalent. There's a lot of third-party packages for JavaScript, you would name it, or have to implement it ourselves. But once again, this is mobile apps, cell phones, things like that, and I think there's not enough real estate to really do much with a tree view or a list view. There's just they're too granular. So these are the widgets which we've initially chosen to implement. So with these limited number of fields, also the number of properties for each field is also pared down. Once again, we've implemented the ones that are the easiest, some that have the very same functionality as they do in the web browser, things like foreground, background colors, sizes, positioning, things like that. Those get written in CSS, and we do support them. We will support a lot more in the future. Another thing is that the field properties themselves, because right now we're only using CSS, they're static. Currently, in your OpenROAD application, you can't go and, using 4GL code, dynamically change the background color of a field or the foreground color. That's kind of hardwired when the frame comes up. This will change in the future. So at this point in time, we only support a few or a limited number of field properties. We would like to change this. Another thing is that entry fields. With OpenROAD, you can have sort of what we call like templates, input masking, validation. I'm sorry, things have got to be typed in like in whatever telephone number format. We do not have that right now, but we hope to do that in the future. Once again, that's part of being able to validate data entry. And so we would like to, in the future, support input templates and validation. Another thing is, right now, everything's got to be really what we call a single page application. We do not support call frames, open frames, and go-to frames. But to get around that, that's why we have cur bias. So right now, I'm just as of this date, to do a application that simulates multi-pages, you have to do it by making composite fields visible and making other ones invisible, and use that type of process rather than doing calls. So it'll appear to be like several pages, but it's actually sort of a trick of hand, smoke and mirrors, where it's all being done by making things visible and making other things invisible. Okay, next. Okay, quickly, deployment. These are the instructions on how to take the app that you have, how to WebGen it. You just call w4GL dev, compile app, give it a database name, an application name, and the new flag is -js, which says, oh, create this JavaScript file. That gets the WebGen going. And then on this slide is how to sort of deploy it in like a Apache Tomcat web server. We also have another utility, which I'll quickly mention. It's hot off the press. I believe it's called, it's Json Config for app, which will actually set up the configuration where you specify which procedures in the OpenROAD server can be called. Here's a quick little application. I'll just go quickly through it. We have a little calculator app. Here it is. This is the OpenROAD version. It basically has a sort of a composite for doing arithmetic, a composite for doing floats. Here's a sample of the 4GL script. Basically, what happens when you tell it to do an integer calculation, what happens if you have it to do a float. Depending on what's in the option field, it'll either add, subtract, multiply, or divide. This is the command to do the WebGen. This is what it looks like in Firefox. Pretty close. You can see it has the integer composite field and the float. And here's what it generated. This is the JavaScript. This is just an extract. And so you see, this is the JavaScript generated. And I actually can read this. It takes a little bit of practice, but you can see, I can see that it's using the component for an integer field, and it's checking. It's doing it, and it's just basically adding two of them. And here's a sort of a snippet of the HTML. You can see on the top, there's a color. Those in purple are the CSS. You'll see down on the bottom, the ones in blue are actually it's using view components, entry field, option field. So it generates CSS. This is an example of it with the HTML, and this is also an example of the JavaScript. And so please help us help you. If you have any questions whatsoever, or comments or suggestions, please give me a buzz. And thank you very much. Hope you enjoyed it.